So in the UML, the minus or plus means whether it's public or private. There's a third category called protected, which we don't need to talk about until we start talking about inheritance, which is more a advanced Java topic, and I really hope that you all take advanced Java next semester. It's a classroom lecture rather than a remote class, although you can take it remote as well, right? That's the best way to take it, I think, is that in an in-lecture environment. So we could create a UML and then implement a class based on that. Like we're going to create a class that represents a fraction, an uppercase and a lowercase. And I'm not sure how far we're going to take this, but we'll start it off. It's going to be called fraction. That's the name of the class. And it's going to have a private variable. That's what the minus sign means. Oh gosh, I'd be dangerous if I could remember what you called the top and the bottom bar. The numerator and the denominator. The numerator and the denominator, both of which are going to be ints. We're not going to allow any 2.5 over 4s. So that's an int. Then the numerator is the int, and the denominator is also an int. Since these are private, we're going to have getters and setters for each one. But we might be able to just give them if we don't want to, but why not? And so the getter has to return the same data type. So get numerator doesn't accept any data, but it returns an int. Get denominator doesn't accept any parameters, but it returns an int. And then set numerator does take a parameter, which is the numerator, which is an int, but it doesn't return anything. And it'd be kind of neat if you could actually program in this. I mean, we sure are making something that looks like a program, but its syntax is completely wrong. And the reason for that is that you can take this UML and you could implement it in any object-oriented programming language, Python, C#, you know, whatever. And then set denominator, which takes a denominator as its parameter. That denominator is an int, but it doesn't need to return anything, so that's a void. And then how about a calculate, right, that expresses it as a fractional value, right? So if it's 1 over 2, it's going to give us a, 0.5 when we return it. Or get value, right? Something like that. Get value doesn't accept any parameters, doesn't accept any arguments, so has no parameter variables, but it does return, it better return something that can support fractions. And we're going to try to be really cool and make it so that we can multiply one fraction by another. So we're going to need a multiply. Multiply, which takes another fraction. And we could do add and divide and stuff like that as well. But, if you do add and divide and stuff like that, when you add two fractions, you have to convert them both to having the same, denominator. And, well, that sounds like a homework assignment. It's too hard for me in here. I'll make y'all do it. Yeah, we'll see about that. Okay. So that is our UML. We can write this class in our lecture. Now here's not what to do when you're writing this. If I give you a homework that says write a fraction, quite often here's what people do. I'm going to make a new project and I'm going to call it fraction. Makes sense, right? That's what the homework is about. But if you do that, then you're not going to be able to add all the data members to your fraction class, or once you do, you're going to have a main method inside your fraction class and it's going to be all confused. So make your client code, your driver code, stored in its own .java file, right? And just name that after the lecture or whatever. or the homework number, or something like that. Do not call it the name of your data class. And in this case, our data class is called fraction. Create your main first, and then create a class. That's your data class. So as far as I can tell, we're on lecture QRS, lecture S. I'm going to get rid of the package. And if I was a good programmer, I would go and I would create my fraction class in a separate file. Today I'm going to be a good programmer. Don't ask me why, I just feel like it. So I'm going to come down here in my project list, find lecture S. I'm going to click above it, right click, and do new Java class to create another one in the same directory. And it's going to be called fraction. Now our fraction class had several members. 2 specifically. Can you scroll over like that? Get you over here. Alrighty. So it had 2 private members, and they are ints, right? So private int numerator, or numer is what I called it. If you feel like spelling the whole word, go for it. And whoops, rova. Private int denominator. I'm going to be totally lazy and let NetBeans build the getters and the setters. So I'm going to highlight those 2 things, choose refactor, encapsulate fields. And I'm going to say, yeah, go for it. Refactor everything. Now, one thing I don't like is that it puts the variables down below all the getters and setters that use them. I don't really know why it does that. So I'm going to cut those 2 variables and move them back up to the top where they should be, in my opinion. Now all of a sudden we have our code littered with comments. If you feel like it, you could remove those comments. All right, so we have the getters and setters. Let's compare them to our UML to see that they look the same, right? Plus get numer, public int get numer. It is supposed to be an int. Yep, that looks right. Get denominator is supposed to be public int get denom. Yep, that looks right. How about set numerator? It returns a void. You could scroll over and see that, right? Its name is set numer. It's got a plus, so it's public, and its parameter is an int, right? And so this dot numer equals numer. Down here, this dot denom is equal to denom. All right. If I want to use one of these fractions, here's how you use it right now. If I go back to main, I could create a fraction object. Fraction, why don't I zoom it out now? F1 equals new fraction, parentheses in parentheses, F1 dot set numerator is equal to 1, and F1 dot set denominator is 2, so it's 1 over 2. If we were really, really cool, we'd make it so that it got simplified. Because if you said 2 over 4, it's really equal to 1 over 2. We could work on that later. We might spend the whole class period working on this class if and we feel like it. Wouldn't it be cool if we could do this? Fraction F2 equals new fraction 2 over 3. What am I going to have to add to get that to work? What's the name of a method that is called by the new keyword? So the definition might be a blank is a method that has the same name as the class, no return type.
Void, like a void?
It's not a void. You're right, a void doesn't return anything. It's a constructor. A constructor is a method that has the same name as a class, no return type, and is invoked by the new keyword. We're going to do that. We're going to go add a constructor to it. Now I'm going to show you a cheap and easy way of doing it, and then recommend you don't do it unless you know exactly that this is what you want. You see the error here? It's telling us this is not a valid constructor. There is no constructor. Well, if there's no constructor, how did that work? Because Java gives you a default constructor, which is one that accepts no arguments. Just gives it to you automatically. You don't have to add it. You can, but you don't have to. But if I click on this error, this is pretty much the only time I ever want you to pick it where it says create. Usually it's a very bad thing to click the thing that says create. Like what if you don't type this, scanner SC, and you came over here and you clicked on that, and it says add import, and it said create. Creating would be a very terrible thing to do. You would not be able, you would not get a scanner that you could use for input. Instead, you'd be trying to write your own scanner class. We don't want that. In this one case, though, since I have that method there, NetBeans is smart enough to figure out what the method's going to look like in the fraction class. So I'm going to do this. Create constructor in fraction. Well, that broke this one. The reason why is once you add a custom constructor, let's go look at what that custom constructor looks like. Looks like this, right? That's a custom constructor. It accepts data. Java removes the default constructor it was previously giving you. A default constructor is one that doesn't accept any data. It doesn't have any parameter variables. So I'm going to let Java NetBeans add that one too. So I'm going to click on that error and get create constructor. Now the functions it created don't work, right? If I run it, it crashes. I mean, it can't do everything, right? What it's doing is it's giving me the framework for running it, but then when I come over here and try to run it, why is it saying build failed? Can I increase the size of my output window? Where's my output window? Oh, it's over here. All right. It tried to run and it says unsupported operation exception. Why did it do that? Well, let's click on the error message. And there it is, right? It created the method for me, but it added this stuff in here to prevent it from actually working. It's telling me you've got to fill this in, right? It's like buying something from IKEA. You get the package, but you have to build it yourself. So this is the default constructor. Let's say that if we create a fraction and don't give it any data, that it sets the numerator and the denominator equal to 1, right? Because 1 over 1 is a valid fraction. It'd be a good default for it. This dot numer equals 1. This dot denom equals 1. So that takes care of the first one, right? This constructor here, after that runs, the fraction is going to equal 1 over 1 until we do that, right? Until we set those values differently. This one needs modification now. I certainly don't want it to throw an exception. That causes it to crash, intentional crash. For one thing, we need to give I and I0 better names, right? This is the numerator and this is the denominator. So int numer, int denom, this dot numer equals numer, this dot denom equals denom, and I made a misspelling there. It's not number, it's numer. Now our code's working again, such that it is, right? I mean, we're not calling calculate or whatever, so we don't know what the results are, but at least it compiles. We need that calculate method. I don't think we ever implemented it. I think we put it in the UML, but we didn't put it in the code. Right? Get value. We need that one. I don't care where we put it, below the getters or above the getters. My one rule of thumb is I like to see all the constructors up at the top. The getters and the setters are kind of not so important, so I don't mind if they're at the bottom. But this one needs, what is the return type of get value? It's a double, right? Oh, and by the way, although it didn't add the word public to your constructors, technically it's correct. Public, not public, public fraction and public fraction. This is the default constructor. We didn't even have to add that until we added the customized constructor. This is the custom constructor, but it's got a more technical name than that. That's like the English version, right? The techie name for it is parameterized constructor. Why is it called that? Because it accepts parameters. But let's add our get value function. Function, slap me, it's a method. Public double, because according to my UML, it returns a double, right? Get value needs to return a double. Does it have any parameter variables? No. And it's called get value. Get value, parentheses in parentheses. Now it's going to we're not going to like what we get if we try to divide by 0, and we don't have any error handling in this. We might want to put some kind of error handling so that if you set the denominator to 0, it doesn't let that happen. We would do that in set denom. But let's do this. Double R for return value, right, or V for value, is equal to this dot numer. And then V equals V divided by this dot denom, return V. Now I'm going to ask you a question. Why didn't I simply do this? Return this dot numer over this dot denom. Can you think of a reason why? There's more than one reason, but there's a big reason. I'll give you a clue. If the numerator was 1 and the denominator was 2, this would return 0. Why would it do that? Do you remember about what happens when you divide an integer by an integer? I'm going to look at Lindy, because I believe you took C++, did you not?
I did.
So if you divide an integer by an integer, what kind of product do you get? You get an integer. Yeah, so 1 divided by 2 turned into an integer, meaning a whole number, it rounds down. So 1 divided by 2 rounded down is 0. We don't want that. So to prevent it from doing integer math, I stored it in a double, and then I divided it by the other so I could return it. So the reason this would have been wrong is it would have done integer math, which works great if the fraction is 4 over 2, but fails really badly for anything that's going to have a decimal point. Let's get rid of that. All right, we're going to come back over here to lecture S. And now that we have these two fractions, let's get the values out. Double V1 equals F1 dot get value, parentheses in parentheses. Double V2 equals F2 dot get value. I typed in 2 equals. No, I didn't. The keyboard did. Get value. I blame it. Get value, parentheses in parentheses. And we could print them out, right? System dot out dot println V1 in parentheses semicolon, and the same for V2. All right. And 1 over 2 is in fact 0.5. And 2 over 3 is in fact a whole bunch of 0.6s. Wouldn't it be neat if we could just print the fraction itself? Wouldn't it be neat if the fraction printing was as easy as doing this? System.out.println parentheses f1. Please print that fraction. And doing the same thing for f2. Well, it's going to print something, but it's not going to print anything useful. It prints out the name of the class. F1 and F2 are both fractions, and then this kind of hashed memory address or something like that, this identifier that makes no sense to humans. If we want this print statement to work, we're going to have to go and add another method to our fraction class. And the method is called toString. It'll convert F1 to a string. It'll convert it, whatever fraction it is, to a string. So let's go back to the fraction class, and we're going to add a toString method. It follows a very specific syntax. Add a toString method to your class if you want it to be able to be printed easily. So prof's rules of classes as they exist so far. One, start with an initial cap. 2, put in a file with the same name. 3, we should always do this, and yet I violate it all the time. Each class in its own file. 4, data private. 5, methods public. And 6, add getters and setters. Anybody remember the technical name for a getter? As soon as I fix the quiz, y'all are going to have to take the quiz, and you'll certainly remember after that. A getter is called an accessor, and a setter is called a mutator. But you notice even NetBeans called them getters and setters, so we don't have to use a computer science fancy name for it, but you better know what it is, so that if you're talking to somebody else and you want to use the correct terms to impress them, you'd call it accessor and mutator. Access because it accesses the data, mutator because it mutates it, it changes it. Now where was I going? Oh yeah, a toString method. That would be another rule. 7, add a toString, whoops, lowercase t, toString method if you want to make it easy to print the object. If you don't care, you're not going to print the object out, you don't need a toString method. Now each time I do this prof's rules of classes, I may word them a little bit differently. After a while, I'll stop saying start with an initial cap, put in a file with the same name, each class in its own file. Right? Because those are just pretty much laws rather than prof's rules. Or when I say laws, they're recommended Java preferences. I didn't make them up. Here they are. Those are the really important ones to me. Data private, methods public, add getters and setters, and add a toString method. Well, let's do that. Let's add a toString method. It's got a very specific syntax. Looks like this. Public string toString. Let's go and modify my UML to match what this is going to look like. Plus toString. Doesn't accept any variables, so nothing between there, but it returns a string. Doesn't accept any parameters. Don't need any parameter variables. But we're going to build the string. String s equals I don't know, what are we going to do? The word fraction, space, or parentheses, I don't know, end quote, plus this dot numer, semicolon, and then let's append something else to it, s plus equals a slash like that, so it'll be 1 over 2, right? So quote slash quote plus this dot denom plus quote closing parentheses end quote, right? And then lastly return s. So what it's going to say, it's going to say fraction parentheses 1/2 in parentheses, something like that. We could even print its value, right? We could call the get value, but I think this is enough. Enough for now. It's got this little warning here. You can follow that warning recommendation if you want. It just adds a little special comment there. Don't need to talk so much about what that special comment means. But every object has a toString method already. Otherwise, it wouldn't have been able to print anything, even when it just printed its name, you know, followed by that @ sign and some numbers. What we're doing is we're giving it a more specific toString method, and that's called overriding. We're replacing the one that comes built into the object class with a better one. All right, and there it is, right? It printed out fraction 1 over 2, and it printed out fraction 2 over 3. Let's go back to main and make that a little bit better. Print f1 equals end quote plus, whoops, f1 equals end quote plus f1 plus quote equals end quote plus f1 dot get value parentheses in parentheses in parentheses. And I'm going to make f2 to look just the same. And as a matter of fact, it looks so much the same, I'm going to copy and change all the f1s to f2s. So when I run it, the output's going to be a little bit more sophisticated, a little more complete, right? f1 equals fraction, 1 over 2 is equal to 0.5, f2 is a fraction, 2 divided by 3 equals that. Now we could have even put that part inside the toString method. So what did toString do? It let us print the fraction out like that. If we did not have toString, I'm going to comment it out momentarily, don't do this. If we did not have toString, then when I ran it and I tried to print that data out, it would look a lot uglier, right? Fraction f1 equals gobbledygook, right? f2 equals gobbledygook. So to make it easy to print the fraction, I added the toString methods. Anybody have typos that you'd like eyeballs on? We're all good? Alrighty. Last two things that'd be fun to add would be a simplify method and the multiply method. Why am I choosing multiplication? Because it's easy. It's just a denominator times a denominator and the numerator times the numerator. It's the easiest calculation of all. And simplify, what are we going to have to do? We're going to have to find the least common, or the most common denominator and divide one into the other. You know what? I may skip that. Or I could assign it as homework. I keep saying that. I'm not really planning on it. But let's do the multiply thing. What is multiply going to do? Did I give a, yeah. It's public. It's called mult. Its parameter is of type fraction. So, public But I didn't specify a return type, did I? No, I didn't. It's void. It's not going to return anything. So public void mult, and it accepts another fraction. Fraction other. And so we're going to say this dot denom equals this dot denom times other dot denom. And this dot numer equals this dot numer times other dot numer. And you're probably wondering why I did it like that when I could have just done this. This dot denom times equals other dot denom, right? That would have been the fast way to do it, fast way to type it. At that point, we ought to simplify the fraction. But that involves calculating the greatest common denominator. That'd be an interesting method to write. I don't know if it's really germane to this example. So I need to multiply those two fractions together and then print out the results, right? 1/2 times 2/3 is going to be 2 over 6. If I'm doing my math right. So let's go modify main to do that, right? So F1 dot multiply by F2, and let's print out F1 again. I'm just going to copy that. Or I could just print it, right? I don't have to copy the whole thing now. System.out.println parentheses quote F1 now equals space end quote plus F1. I'll never understood what it's doing down here. You'd think that if it's 100% done, then that would go away. Cancel it? Okay, fine. All right, anyways, run it. After doing the multiplication, it's now 2 over 6. Let's take a vote. Do we want to write a simplified function or not? Thumbs up or thumbs down. Who's interested in the math involved in calculating the greatest common denominator?
I'm good either way.
Lindy's good either way. I'm going to take that as permission to do it. All righty. So a method that calculates greatest common denominator. Do we really want that in the fraction class? I don't know. It just seems like some kind of math that it needs to do. Like it should be in a separate class. However, we don't have a separate class. Let's add one. So we're going to go back to projects, back to default package. Thank you for giving me an answer, Lindy, because nobody else was willing to say yes or no, even though they're all thinking, oh, heck no. All right, so new Java class. These are mathutils. So I'm going to call it Matthew. That did not mean to come out the way I just said it. Mathutils. Or how about Mathutil? Tils. How about I type it with a capital U2? Mathutils. This class is going to have something called greatest common denominator. We're going to make it static so that you do not have to instantiate. You do not have to create a Mathutils object. In order to call getValue, we had to have a fraction in order to do that too, right? So that's called an instance method. We had to have an instance of the fraction in order to call getValue. But we don't have a Mathutil object we're going to create in order to just calculate greatest common denominator. Okay, so here's what we're going to do. We're going to write a function, but we want to be able to call it without having an instance, which means we have to make it static. Static means it's a class method. it runs based on the class name rather than on any particular instance. So public static int, I think we can safely assume that the denominator and the numerators are always going to be ints. Get GCD, greatest common denominator, and it's going to accept two variables, int x, int y. Or how about we say get in n and d? Because I want us to, I'm tempted to just cheat and Google up how to get the greatest common denominator. No, I don't think it's necessary. I think we could have just left it x and y. Every pair of numbers is always divisible by 1, right? So int GCD is going to start off at 1. And then we're going to have a for loop that goes to the maximum value of either n or d. Actually, it could go to the minimum value, right? Because if it's calculating the greatest common denominator of 2 and 6, we don't need to try 3 and 4 and 5. So let's declare a variable called upper, which is equal to math.min, the minimum value of the numerator or the denominator, right? That's our upper limit. The GCD is our lower limit. So for or while, let's do for so that we just have a variable. For int I equals GCD, semicolon, I is less than or equal to upper, actually, semicolon, I plus plus. And what are we going to do? We're going to divide both numbers by I. And if they divide evenly, right, like if it's 2 over 4, we divide 2 by 2, and we divide 4 by 2. And if they divide without any remainders, then it's good. It's all goodness. So if, parentheses, n modulus I equals 0, and d modulus I equals 0, then that's our new candidate for the greatest common denominator. GCD equals I. Right, so say that n is equal to 3 and d is equal to 6. Or n is equal to, n is 4 and d is equal to 8, right? 4 eighths. We want it to eventually equal 1 over 2. So 4 and 8. The minimum of those is 4. I is going to count from 1 to 4. Is 4 and 8 divided by 1? Are they evenly divisible? No remainders? Yeah, they are, right? 4 modulus 1 is 0, and 8 modulus 1 is equal to 0. Great. So that's our greatest common denominator. Factor. I think I'm calling it the wrong thing. Greatest common factor. That's what I should have called it. It's not a denominator. So G, oh, they do call it D at some point. I feel like calling it F. Get GCF. Returns the greatest common factor of n and d. In other words, the largest number that evenly divides into both of those. I think we're done with it, actually, honestly, except for the return statement. Not return 1, that's stupid. Return GCD. I don't know why I'm not changing that GCD. I could do a refactor on it and call that GCF as well. I'm going to click it, choose refactor, rename, and I want to rename it to GCF. There. Let's build it, even though we're not using it yet, just to make sure we don't have any syntax errors. All right, good. It built cleanly. Looks like it did. Anybody still need this page up? All right. So, the simplify method. We're going to come back and we're going to write a method called simplify. And it doesn't need to return anything. It's just going to make it, simpler. So public void, because it doesn't have to return anything, simplify. And it doesn't need to take anything either. Like that. So let's get the greatest common factor. Since this is a static method, we access it by its class's name. So int GCF equals mathutils dot get GCF of the numerator and the denominator. And then we're going to divide both the numerator and the denominator by the GCF, right? Because if it's 2 and 4, the greatest common factor is 2. And then so it's going to divide 2 by 2 and 4 by 2 to simplify it. And if you hated math and don't really care about all that, that's okay. So, technically, everywhere else I've been calling numer this dot numer, so I'm going to add that. As you see, it's not strictly necessary. The only time it's strictly necessary is if you have a variable with the same name as the member, like we do here. But I think that it makes the code clearer. Your opinion may differ. So this dot numer and this dot denominator. And so then we're going to say this dot numer divide equal GCF. Divide that numerator by the GCF. Now I don't know why I'm doing it that syntax when I didn't do it down here like that, but whatever. This dot denominator divide by equal by GCF. It is now simplified. And boy howdy do I hope I actually have the math right and I don't spend 10 minutes chasing down something. Allow me to test it before. I'm going to go back over to lecture S and I'm going to make a fraction that's equal to 2/4 and then I'm going to simplify it. And I want it to say 1 over 2, right? F1 dot simplify. And so 2/4 did simplify down to 1, 2. So after we do our multiplication, why don't we simplify it? Or maybe multiplication ought to simplify automatically. If that's our decision, we should go to fraction.java and simplify it as soon as we multiply it. This dot simplify. And honestly, the constructor should simplify it as soon as we create it, right? Because if we create it with 2 over 4, we'd rather already be 1 over 2. So I'm going to come up here to the constructor, the parameterized constructor, and I know I've made a whole bunch of changes, and if I need to spin around and go back to them, let me know. After we set the numerator and the denominator, we're going to call this dot simplify. So now I shouldn't even have to call. Oh, he's giving me a little warning here. Make the class fraction final. I don't remember why we'd want to do that. If I did that, the class would look, it would have the final keyword there. I'm going to undo that change. Alrighty. So with that change in place, by calling simplify inside fraction and also simplify inside mult, then as soon as the math is done, it should be simplified. So I should not even have to call simplify. And if this says 10 over 5, it should get simplified to 2 over 1, right? So created as 10 over 5, which it still says 10 over 5. It didn't simplify. Oh, that's because if we're setting the values by hand, right? And so simplify never got called. We could simplify every time we set any part of it. Seems a little excessive. But if I go back to my fraction class and every time we change the numerator or the denominator, we would want to simplify it. So this dot simplify, parentheses in parentheses, for set numer and also for set denominator. This dot simplify. Does that make sense? Every time you change it, we want to simplify it again. Because if they set the fraction equal to 1, 2, and then later on they change it to 10 over 2 by setting numerator, we want it to be simplified right away. All right. And it did. It got simplified right away. And when we did the multiplication, it wound up being 4 over 3. Hope that's right. 2 times 2 is 4. 1 over 3. Let's create a product that would also have to be simplified, right? So if I go back to main, my first value is 10 over 5, and my second value is, I don't know, 4 over 20. Wouldn't that have to be simplified? Because it would be 40 over 100. Yeah, definitely would need to be simplified. All right. And it was. Okay, I'm pretty happy with that. It's almost to the point where I would almost feel comfortable telling you that I want you to add the division and the add and the subtract methods. Yeah, I think I'm going to be a meanie and do that. Howsoever, if you get stuck on it, I will send you the equations for add and subtract and divide, okay? So our homework, take our fraction class and add 3 more methods to it. Void add, which takes a fraction called other. Void subtract, which takes a fraction called other. And void divide, which takes a fraction called other. Now divide is also easy. It's as easy as multiplication. You just multiply the top by the bottom and put that in the top, I think. And you multiply the bottom times the top and you put that on the bottom. Let me see if that's the truth, right? If we have, don't type this bit down here, 1 over 2, and you multiply it by, 4 over 3. No, if you divide it, then that's equal to 1 times 3. You do cross multiplication. 1 times 3, top times the bottom. So that's 3, divided by 2 by 4, which is 8. I believe that's correct. I believe that's correct. The formula for divide is numerator equals numerator times others dot denominator, whereas the denominator is equal to the denominator times the other's numerator. And then you'd want to simplify it. You're going to have to look up how to do addition and subtraction. That's a slightly more complicated process. Fortunately, with the simplify function hanging out, you could do it in the least efficient fashion possible. Feel free to Google. Feel free to look up code how to do this. I'm not going to yell at you if you go and Google up some code that shows you how to, calculate the numerator and the denominator, for add and subtract. Make sense, gang? Anybody have typos that you wish were all taken care of? Everybody get to take advanced Java. I'm not going to let you leave the room until you say you are.
I'm enrolled.
Yay, at least one of y'all. All right.
I will be enrolled.
Yay, good, 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 good. And hopefully some other folks will too, because the class wouldn't make with just two. All right, let's stop. Or, oh gosh, how long was it paused? I hope it wasn't paused for a long time. I guess I'll find out. I mean, everybody's here, but I want to modify this. We added another method, didn't we? Besides toString and mult. What was the last method we added? It wasn't the getGCF because that's part of a different class, but it uses getGCF. So which method? And you may have already told me the answer and I just didn't hear it because I'm deaf.
Simplify?
Simplify, right. So it's public. What does it return? It didn't return anything, so it returns void. And it doesn't accept any parameter variables. We also had two constructors. So we're going to modify this to have the two constructors as well. A constructor has the same name as the class, but no return type. We had one that looked like that, and we had one that looked like numerator, which was an int, and denominator, which was an int. I believe that's a pretty complete version of the UML for our class. All we're going to be doing is add several more. We're going to do add, which takes an other of type fraction. We're going to do subtract, which takes a variable called other of type fraction, and divide, which takes other of type fraction. Alrighty. Good enough? Y'all mind ending class 5-10 minutes early? I don't. All right.